James, like countless others from Aristotle to Oprah, has spent much of his life trying to understand why habits exist. But only in the last 2 decades have scientists and marketers really begun to understand how habits work, and more importantly, how they change. What was the first thing you did when you woke up this morning? Leap under the shower, check email, or grab a donut off the kitchen counter? Do you brush your teeth before or after taking a bath? Which way did you drive to work? When you got home, did you put on sneakers and go for a run, or pour yourself a drink glass and sit down to dinner in front of the TV? William James wrote in 1892, "Our whole life, so long as it is in a certain shape, is a mass of habits." The choices we make every day may appear to be the result of well thought out decisions, but they are not. These are habits. And although each habit doesn't matter on its own, over time, what we order to eat, save or spend, how often we exercise, and the way we think and work routines can change. We nurture, they have a huge impact on our health, productivity, financial security and happiness. A paper by a Duke University researcher published in 2006 found that 40% of the actions people take were not actually decisions, but habits. At some point, we all consciously decide how much to eat or how to focus when we get to work, how many drinks to have, and when to go for a run. Then we stopped making choices, and the behavior became spontaneous. This is a natural consequence of our neurology. And by understanding how this happens, you can recreate those patterns however you like. The Trap of Habit: How Habits Work. The building that houses the Massachusetts Institute of Technology's (MIT) Department of Brain and Cognitive Sciences also houses laboratories that may appear to the casual observer to be dollhouse versions of surgical theaters. It has tiny scalpels, drills, not saws, smaller than a 1/4 inch, attached to robotic arms. The operating tables are also small, as if made for child-sized surgeons. Inside these laboratories, the skulls of sedated rats are cut open, and tiny sensors are implanted inside and that record the smallest changes inside their brains. These laboratories have become the epicenter of a silent revolution in the science of habit forming, and the experiments conducted in them explain how we develop the behaviors essential to everyday life. Laboratory rats shed light on the complexities that go on in our brains when we do something as simple as brushing our teeth or backing out of a car while driving. Towards the center of the skull is a golf ball-sized tissue mass similar to the ones you can find in the heads of fish, reptiles or mammals. It is the basal ganglia, the oval cell mass, that scientists did not understand well for years, except for suspicions that it played a role in diseases such as Parkinson's. In the early 1990s, researchers at MIT began to think that the basal ganglia might also be important for habits. They discovered that animals with damaged basal ganglia had problems running through a maze and remembering to open food containers. They decided to conduct experiments using new microtechnologies that allowed them to observe the minute details that go on in the minds of households as they perform dozens of routine tasks. Finally, each animal was placed in a T-shaped maze with chocolate placed at one end. The maze was designed such that the rat's location was behind a partition that opened when a loud click sound was made. When it clicked, it usually wandered back and forth in the central corridor, sniffing the corners and scratching the walls, hearing voices and watching the partitions disappear. He seemed to smell the chocolate, but could not figure out how to find it. When it reached the top of the T, it would turn right, away from the chocolate, and then sometimes, stopping for no apparent reason, would turn left. Finally, most reward was available. But there was no discernible pattern in his disorientation. It seemed that every rat was walking freely, without thinking. However, examining the heads of the rats told a different story. The rats stopped smelling and taking wrong turns. Gradual changes. A series emerged. Instead, they started moving faster and faster through the maze. And something unexpected happened in their brains. As each mouse learned to find its way out of the maze, its mental activity decreased. As the path became more and more smooth, each mouse began to think less and less. It seemed as though the first few times the rat found its way through the maze, its brain had to work at full capacity to process the new information. But after walking the same path for a few days, the mouse no longer needed to scratch the wall or smell the air, and so the brain activity associated with scratching and smelling died out. It no longer needed to choose which direction to turn, so the decision-making centers of the brain became quiet. As each creature wandered through the maze, its brain, and especially its basal ganglia, were working frantically. Creatures its brain every time a mouse sniffed the air or scratched a wall, its brain exploded with activity, as if it were analyzing every smell, sight and sound. During its entire disorientation, the rat was processing information. The scientists repeated the experiment over and over, observing how the activity changed by walking the same path hundreds of times. Friends, with this we bid you farewell and see you with a new book with a new perspective. Goodbye until then. The rat had adapted to running through the maze to such an extent that there was no longer any need to think about it. But mind observations indicated that adoption was dependent on the basal ganglia. As the rat increased its running speed, this tiny, neurological structure seemed to dominate and the brain was doing the least amount of work. The basal ganglia was central to remembering and working on patterns. In other words, when the rest of the brain goes to sleep, the basal ganglia store the habits. Thank you my dear, please subscribe this channel.